Okay, should be good to go now. Let me talk a little bit so we can check on my audio levels. And all right, sounds good. I'll, uh, I'll try to keep an eye on chat, so if I start having the weird audio issues again, maybe I'll catch it this time. But anyway, so where we're at. Um, so I actually just went through and did what we were trying to do earlier. Right here, I downloaded the GitLab runner, and then I did an install. This time it all worked as expected. Stupid thing. There we go. Installed like it's supposed to, and came back up. So yeah, I should be good to go to the next step now. But I want to go ahead and merge the change that allowed me to do that. So what that was is right here. Um, Originally, I only had this one security group here, the cluster primary security group. Uh, that I thought that was enough. I'll go back and check it out later. But what I did is I just added in the default security group for the VPC, and those two security groups together give me everything I need to get out and update the get the Yum updates or whatever from the repo. So good to go there. Let me go ahead and kill this, and then we'll pop over here and do a quick merge. Okay. So, typically if this were like a real project and we're being paid to do this, I would actually hunt down and find out precisely what it was in that security group that I needed and add that, make it work and everything. In this case, I'm able to connect another security group that makes it functional. That's good enough for the moment. I'm not being paid for this, so I can go ahead and skip the super professional. But if you're ever doing this, make sure that if you're working for a client, take that extra step, find out precisely which rule it was that wasn't working for you, and then make a conscious decision to either update the security group that you're already using, or update the default security group. Make uh, an intentional choice about what you're doing. In my case, I'm just making it work because I need to move on. I've already spent a little bit too much time on this. So yeah. Anyway, so once I've done all that, I do have my CS runner here that I just redeployed, which is actually running out, not just initiated. And then, like I said, I downloaded the file, ran a DNF. And by the way, this is kind of a helpful tip for you guys that don't do a lot of Linux administration. So this sudo dnf install GitLab runner blah blah blah. When you use DNF to install an RPM or Yum, if you're using Yum, whatever, uh, it'll automatically resolve those dependencies and download them and basically do exactly what you need in order to get it up and running with one command. So just a handy install. You'll often see, in fact, I think the instructions, yeah, see the instructions here say, install with RPM I. Yeah, the issue with that is that you can do that and it'll install it, but it'll also throw errors telling you it needs these dependencies and stuff like that. You're just way better off using an actual package manager like DNF because of the fact that it'll find these dependencies, let you know what they all are, resolve them all immediately, and then just basically say, hey, for 616 megs, I can solve all these problems for you. Do you want to do that? Yes, I do. And then boom, you're done. All right. So, okay, moving on. So the next step here is not that. All right. So, using binary file. Okay. So now this is where we're at. Step two, we need to give it permissions to execute. So we need to go find this guy, and it should be in user local and chmod exit. So let's just go check to make sure he's there. User local bin. So ls -la user local bin get. Do not see that. So did I type it wrong? User local bin should be there. Oh, it might be that is. Did I type it correctly? User local bin. User local bin. So did it install it all? Okay, RPM. Oh, sudo. Doing this from a laptop. All right. So this shows that we do have GitLab Runner installed. Hmm. So where in the hell did it put those files? Well, either way, we're going to need the user. So let's just go ahead and add this runner. Um, this all makes sense to me. So there's no issues there. Let's just run it. Hmm. So user add, we're basically going to make a new user with the comment GitLab runner. So it'll, if you ever look at the user, it'll tell you it's a GitLab runner. It is going to create the home folder, and its shell will be bash. So let's go ahead and do that. So it says it already exists. All right. Oh, you know what? Ah, yeah, okay, disregard. So we only have to do this if we're using the binary file. The fact that we downloaded the RPM and installed it, that's we're basically done. Okay, so we've got it installed. So now we need to move on to configure. Okay, that was my fault. It's hard reading on this small screen. Okay, so let's see, advanced configurations. Auto scale DC2, that's not really what we want. We're not doing any auto scaling. That's pretty much it. So let's just configure GitLab runner. All right. So it's really weird. It seems like did this not click on the right thing? Hmm. Yeah, because I definitely do not want to use OpenShift. Yeah, you know what? Okay. Actually, I tell you what, let's steps after installing. That's what we need right there. Okay. So we've installed, okay, setup runners. That's actually what we need. Okay. Install GitLab runner, blah, blah, blah. Okay. Runner registration. After you register individual runners, that's what we need. Okay. And authentication token. Yes, that is exactly it. All right. Yes, yes, yes. This is what we need right here. Okay. We are not behind a proxy. Um, so we can just do a sudo runner register, and that should start asking us the questions we need to answer in order to get this guy registered. Okay. Enter GitLab instance URL. So in our case, we are using GitLab.com, so that is absolutely fine. All right. Oh, I guess we have to actually put it in. Enter the registration token. So let's check to see where we get that from. Runner authentication token. I think we need to get that. You can either create an instance group or project runner. Yeah, okay. So let's go ahead and go through what we were doing before. And I kind of stopped before, but we will go ahead and continue doing it now because we're ready to do that. All right, CSCD runners, new project runner. And so these are going to be the tags. How do we tag this runner? I think in this case, we're going to tag it as internal, or we'll call it CS internal. And configuration, yeah, and we're going to lock it to this project because we don't want anyone else being able to do that. So amount of time the runner can run before it terminates. Project has a shorter law. Must be a minimum of 600 seconds. So, 600 seconds would be 10 minutes. Um, let's do, how long do we want to let? You know what? Let's do 10 minutes is probably too short. Tell you what, let's do 30 minutes. That's probably fine. All right. So create this runner, register CalSock internal runner. Okay, it will be Linux. Okay. Oh, there we go. We'll just cancel it and then we'll run their script here. All right, cancel that, and then that's handy. There we go. Okay, that's correct. And we're gonna name this guy, yes, runner, because that's what we're calling it in our documentation. So, okay. Executor. So, what kind of executor do we want this to be? Um, hmm. I think probably shell. Do we want shell? We could do Docker, and then we could execute images on it. So basically, the executor is like what type of executions are you going to do on it? If you did Docker, it would be a machine that would basically spin up like Docker containers and do stuff in that. Um, and then if it's, it's obviously not Kubernetes because it's not running in Kubernetes. Uh, but I'm thinking just shell because for right now that would be easier, and then we could just like issue shell commands to stuff, which is fine for the moment. All right, so that's good. So all that's good. Let's go back and check our manage runners. Oops. Right here. Uh, yeah, let's go ahead and do that. Okay. And then we will finish runners. And then we can see we have the CalSock internal runner here. It is online. And here's how we use that. So, I was talking before about tags and, the reason why we would tag a runner. And what we will do, I'm going to go ahead and create a new branch. Or actually, we'll use the add test app. Um, so actually, before I do that, I'm going to show you a trick. So the add test app, uh, like branch was actually created a week ago. I've made a couple updates since then. And so this code base is actually out of date. There's new stuff. If I go to just regular CalSock, you see like 15 minutes ago, I made some changes here. 3 days ago, 3 days ago. So there's definitely been some changes since I created this branch or since this branch was updated. So how do we roll those changes into this branch? We do what's called a rebase. I'm going to use an easy way of doing this, and fingers crossed it works. Sometimes it doesn't. But what we can do is create a new merge request, and we will merge the test app to the main, and we're going to do a compare branches. But here's the trick. We're going to mark this as draft, and I'm just going to leave that more or less blank. Create merge request. Now, what this actually does is it will create a merge request between this branch and main. But one of the things that you're going to notice is source branches. Hmm, that is interesting. So actually, maybe. Okay, I'm gonna have to look it up because this did not do what it's supposed to do. Usually, with other GitLabs, you'll have an option here that says rebase, and you just click on it, and it'll rebase this branch uh, on the target branch. And for some reason, we do not have that option here. I wonder why. So, helm changes, some minor changes there. Hmm. Maybe it's because all these changes, actually, I bet that's why, because all these changes, there's nothing to rebase. There's no, like, it's not like there's a folder that name changed or there's not a file change. There's nothing in any of these changes that actually needs to be rebased. Uh, and that would be like, let's say I had worked on this variables in one of the other patches and I had changed like this from subcomponent to subcomponent with two T's. Well, now you've got a conflict where the change that has been applied since I created this branch changes the same line of code as something that's in this branch. So now we've got to conflict those two. We've got to decide, do we keep the original change or do we, keep this change? And that's kind of what rebasing is doing. It's saying I'm going to pull all the stuff that's been checked in since I created my branch. Let's see, actually, I think, do they have, yeah, the graph here. This might make it easier to understand. So this add test app, I created it way back here, and I've been working on it. Well, if you'll notice, there are actually several other branches that have been created and merged since then. So, all these changes that have happened since I created it are all merged and they're part of main now. Well, my version of main was way the hell back here, and all that stuff isn't in there. So a rebase literally takes basically all my changes and pulls them out, and then puts them on top of all this. It's almost as if I copied all this original stuff and then pushed a replay button that played all this on top of the existing branch. It's really kind of a hard concept to explain. It's a hard concept to understand because you just I don't have a really a uh, good way of explaining it because it's not a trivial concept to understand, and it really has to do with the way branches work and how revision control between multiple branches work. It's a Git thing. Uh, what you have to do is just play with it a little bit, screw it up a few times, and then eventually it'll kind of make a little bit more sense. Or at least that's how it worked for me. I really struggled, which you can tell by the way that I'm not explaining it very well. I really struggled early on in trying to figure out what the difference between a rebase was and like, I don't know. There's other things that you can do and get. Uh, and if I was more of a software developer, I'd probably understand it better. But anyway, main thing is that I think I can go ahead and merge these changes and they'll go through. So let me go back to this guy. And what I'm going to do is make some changes here because edit. All right. Yeah. So in this case, it's giving us an error. It says, hey, basically your pipeline failed. Well, the reason the pipeline failed is because what we're trying to do here doesn't actually work in our system yet. But that's fine. It'll work soon. What we really want to do is take all this code that I wrote and just put it in main so it's there and it's available. And then we're going to create a new branch. Implement use. So this new branch, we're basically going to change it so that it will use the new internal runner that we just created. And now that's going to give me the chance to kind of explain tags and stuff. Okay, so we have this application stuff here. It's going to kick off these jobs, and in this case, it's running helm.yaml instead of the terragrunt.yaml that we usually see. So uh, that's here. And so what we need to do is we need a way to tell GitLab these jobs, because they're different than the other jobs. The other jobs can run on pretty much any GitLab uh, runner that's available. These jobs are different though, because if you remember, we had some issues before where these guys did not uh, did not work well in or they didn't work because basically it couldn't reach the cube control uh, panel or whatever to execute these kubectl commands. So what we need to do is we need to have these commands executed from inside the environment as opposed from outside. So if I look at my diagram here, so before, GitLab's out here, it's trying to send commands to this EKS cluster to tell it like, hey, spin up these pods, make these changes, whatever. But it can't get in there because there's no this is a private IP address. There's no way to actually talk to it. It has a DNS that resolves, but it resolves to a private IP address. So that's the problem. Now, what we could do is set up a way that we could use the load balancer to port forward that stuff inside, but we don't really want people outside of our environment being able to directly impact our cluster. So that's why we've set up this runner. So this runner is basically phoning home. It's going outside to GitLab and saying, hey, do you have any work for me? GitLab is going to say, yeah, I do. I need you to execute these kubectl commands. So this guy's going to pull the kubectl commands back and then execute them. But because he's inside, when he resolves the domain, it's going to work. And we can test that. We probably need to install some stuff on it for this to work, but we're going to go ahead and tag it. So let's look at tagging. Let's see what is tagging. GitLab runners, GitLab runners. So where does it talk about tagging at here? Pipelines, jobs, should be under jobs somewhere. Okay, here we go. Tags. Tags. This is the tags used to select a specific runner from a list of all the runners that are available. So we need to add tags. And because we want basically all of these Helm type commands to run in this specific, in this runner, the same runner, we're going to add the tags at this layer. So tags. And then what should the tag be? If we go back and look at our runner, remember this guy. Well, actually, we can see right here, the tag is CS internal. So that is going to be what we tag it. Now, what this means is that when this job runs, or any of these jobs run, right now it's just this validate, which is fine. When any of these jobs run, it's only going to use that runner to execute these jobs. So let me say implement. And so what we're going to see, when this guy kicks off, it's going to take a little bit. Oh, something else might have gotten worked up. Okay, I think we're going to have to make a change over here so that we can make it pick it up. All right. So remember, part of the way this works is it checks to see if anything has been changed. We didn't change anything under development. That's why I didn't run that job. And then we also only right now we really only want to kick off the applications because we don't care about any of the stuff, other stuff at the moment. So we're gonna make that change. And there we go. All right. This time we'll get a job for applications. And now, what will happen is this file will get called. This file says, hey, if there's been any changes under applications, we're going to include this Helm, which is what we want. Helm's going to get loaded, and Helm's going to say, okay, uh, I have this job deploy. I'm going to run this, but I'm going to include all this because this is part of the extends right here. This check apps extends this. So we're going to load that guy as well. So let's get over there. It'll take us a little bit to get there, but you should see the applications get loaded up here, and then the Helm, deploy Helm will come up, which is going to fail because we don't have uh, EKS control installed on that guy, so that'll be the next thing. But the main thing that I want to see that we're looking for is when this kicks off, we want to see that it sent it to that specific runner and didn't try to use one of these other runners. Because if you look like here, this guy tells us, hey, the rudder I used was this blue SAS Linux Spal blah 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 rudder, which was not our rudder. We didn't create that. That exists wherever, probably one of the many runners inside GitLab.com. That's not what we want. We want it to use the CS Runner 01. And if we click on that job, which failed, and that's to be expected, see right here, the runner it used was our CalSoc internal runner, which is exactly what we wanted. So perfect. We now have exactly what we set out to do. We have a runner that exists inside Amazon in our boundary. This guy is now where it executes these jobs. So now what we need to do is get that thing set up so that we can issue Helm commands and whatnot to uh, modify this Helm or to modify this cluster and make changes and stuff. So let me think. What is my process going to be? I think um, did all workers stop? Let me go check that. Sorry, I got distracted. Check. I think that guy's still running anyway. I don't think I have to actually run that for it to work. Yeah, we'll find out. Anyway, all right. So basically that's where we're at right now. We have the runner that we need. It is inside of our cluster. That means that it can see the cluster, it can action against the cluster. So now what we need to do is go through the process of getting AWS and EKS control and all sort of stuff set up on there. that is going to be non-trivial. But and then that's going to bring up some other issues. So step one is to figure all that out and do it manually. We want to get to the point where we can execute this job and it actually runs on that runner. That means we're going to have to go and install a few things. We're going to have to configure a few things. It's just going to take some time, trial and error to figure that out. And I'll circle back and do like a stream once I have figured it out. But even then, once I'm done with that, our plan here is that we want everything to be deployed as code. So we have our runner being deployed, but it's just creating the thing. It is not registering it with GitLab. It is not installing stuff on it. It's not doing any of that. So then the next question we've got to decide is, are we going to write code, probably Ansible, that would go out and install all the libraries and packages, do all the configuration and stuff in that box that we need in order to make it work. I don't know that we would do that. That seems a little. It would be good, but I also kind of like the idea of having a little bit of a extra step of control here, because by me manually configuring this and keeping it outside of the normal code base, that does give me a little extra layer of security. So I'm gonna have to think about that. I'm not sure what route I'm gonna do. But anyway, but that's where I'm at right now. So I'm gonna go offline, and over the next day or maybe this weekend while I'm working and thinking, I'll be figuring out what I need to do to make all the ECAS control and stuff work. And once we're done there, I'll circle back, and by then I'll have a better answer on how we go forward. Anyway, that's it. Hopefully that was helpful. And now you know what tags are. You know how they get used and why they matter. You know what runners are a little bit better. These runners are just computers, virtual machines, something that exists somewhere that you can target and execute jobs against. And these jobs are just literally scripts. I could copy this line and run it at the command line, and that would be exactly the same thing as this job doing it. The only difference is that the job comes with it sets a whole bunch of variables that aren't natively set. But yeah, so we are doing pretty well. All right, folks. Hopefully see you. Probably not tomorrow. I'll be traveling, so maybe next week. Thanks.
I'ma keep it.